You are evolving into an anteater. Well, probably not anytime soon, but this is real and probably one of the strangest phenomena still happening in nature today. Many animals in the wild that weren't anteaters have now evolved into anteaters. Take a look here. This is not an anteater. This is not an anteater either. In fact, nothing I'm showing you right now is an anteater. They've all just slowly, over millions of years, become more and more like one. This phenomenon has been so widely studied in science that it has its own name, myrmecomorphism, which, if you break down from its Greek roots, essentially means anteater shaping. The tendency for things to become anteaters. Of course, this sounds ridiculous because it is. But when we look into nature, we see this effect happening everywhere. Some did it millions of years apart. Some did it on totally different continents. Some weren't even remotely related. But why does it seem like this is the ultimate life form for so many animals? What stops us from evolving into anteaters next? And will all roads always lead to anteater? This Anteaterification effect hasn't quite made it into meme culture the way it deserves to, but scientifically, this is actually peak performance for a very specific and surprisingly common ecological niche. But how do we know this? Well, the best explanation goes back to an effect called convergent evolution. Essentially, this is when two different organisms that deal with similar challenges end up evolving the same traits independently. But why anteaters? And why do we see this so often? To get that answer, we need to understand what anteater-like actually means, because not every creature that looks like an anteater is a real anteater. Some, and actually most, are just evolutionary imposters that ended up resembling them. An anteater-like body usually has a long, elongated snout built for probing deep into insect nests. That snout design allows the animal to reach food sources that almost nothing else can access, giving it an exclusive restaurant that it never has to share with anyone. Anteater-like bodies also have an incredibly long, sticky tongue, sometimes longer than their own skull, that can flick in and out hundreds of times per minute to lap up ants and termites faster than the colony can react. Some species can consume tens of thousands of insects in a single day. It's a numbers game, and anteaters always win. These animals also tend to have powerful, heavily built front limbs with massive claws. And those claws aren't just for breaking open termite mounds. They're defensive weapons, serious enough to drive off lions and jaguars. When your diet is so specialized that you've cornered an infinite and self-replenishing food source, and your body doubles as a fortress, you end up in a remarkably stable evolutionary position. But this raises a really interesting point. If the anteater shape is so effective, why isn't everything turning into moles instead? Moles are also insect specialists, also burrowing, also successful. So why don't we see molification everywhere? Well, the mole body plan is built around digging through soil constantly. That's a much more physically demanding niche. You need different musculature, a completely different skull shape, and a body plan that locks you underground. The anteater strategy, by contrast, is remarkably flexible. You walk on the surface, you find a mound, you crack it open, and eat. No tunneling required. You can do this in forests, grasslands, deserts, and scrublands. The anteater body plan travels. The mole body plan does not. So, who was the first anteater to become an anteater? Well, technically, the earliest true anteaters, the Vermilingua, branched off from their relatives around 60 million years ago, right after the dinosaurs went extinct. But the interesting part is that they weren't alone, because around that same window of deep time, completely unrelated animals on totally different continents started independently evolving the exact same toolkit: long snout, long tongue, strong claws, tough skin, to exploit the exact same food source. We don't call true anteaters more authentic or biologically superior to their lookalikes. Most of it comes down to the fact that they were simply the ones we categorized first. Back when scientists were trying to sort animals into groups, they had no access to genetics or evolutionary history. They were working purely on appearance. So the long-snouted, claw-heavy, tongue-flicking creatures from South America became the official template. they were dubbed the real anteaters. In a way, they were the first animals to become anteaters, even though that's a slightly circular thing to say. So what other animals are anteaters that aren't actually anteaters? Well, the most famous imposters are pangolins. Genetically, pangolins are more closely related to carnivores like cats and dogs than they are to true anteaters. They're scaled armored mammals from Africa and Asia, and their last common ancestor with South American anteaters goes back so far that it was probably a small generalist mammal shuffling around in the shadow of the dinosaurs. And yet, put a pangolin next to an anteater and the similarities are almost eerie. Long snout, long sticky tongue, powerful digging claws, specialized diet of ants and termites, no teeth whatsoever. They solved the exact same puzzle using completely separate evolutionary toolkits on opposite sides of the planet across tens of millions of years of independent history. And then there's the Aardvark. Oh, the Aardvark. The Aardvark isn't a pangolin. It isn't a true anteater. It isn't even particularly closely related to either. It's so genetically isolated that it sits in its own order, Tubulidentata, essentially alone on its branch of the mammal family tree. And yet, there it is. Long pig-like snout, long sticky tongue, big digging claws, eating ants and termites every single night. If you showed a picture of an aardvark to someone who'd never seen one and told them it was some kind of anteater, they wouldn't question it for a second. And carcinization. Wait, wrong script. This anteaterification has occurred in body forms before modern anteaters even existed. Fossils show extinct creatures with convergently evolved elongated snouts and reduced dentition that were clearly exploiting insect colonies millions of years before the modern anteater lineages showed up. Evolution can't seem to help but keep wanting to make more anteaters. But if the anteater design is so powerful, where are all these ancient proto-anteaters now? Well, most of them are completely extinct. The problem was they literally weren't good enough at being anteaters. Some lacked the fully reduced teeth that true anteaters eventually lost entirely. Others didn't develop the tongue fast enough to compete. And a few were living in ecosystems that collapsed during mass extinction events, which, again, is not entirely their fault. But even when their lineages died out, evolution rebuilt the design somewhere else. It's almost hardwired into the way life works in insect-rich environments that this body plan will keep re-emerging. The anteaters of today are the most refined versions of this blueprint that have existed so far. But what else could turn into an anteater? The honest answer is anything eating enough ants in the right environment. We've already seen it happen in mammals across 3 or 4 completely independent lineages. Even some lizard species are showing early signs of snout elongation and tongue specialization as they shift toward more ant-heavy diets, baby steps on the long road to anteater. But in reality, this process is largely limited to certain groups of animals with the right starting blueprint. We won't be seeing wolves becoming anteaters anytime soon. Their body plans are built for completely different ecosystems, and the structural changes required would break their ability to function long before they became effective insect specialists. Humans, especially, as the dominant species on the planet, are not on track to develop elongated snouts and sticky tongues. You're safe. For now. But something really interesting to consider is that other animals have evolved similar strategies to anteaters for similar reasons, even without looking like them at all. Take the star-nosed mole. It isn't an anteater, not even close. But it evolved an extraordinarily specialized face built for detecting and consuming invertebrates at incredible speed. Because exploiting small, abundant prey that other animals ignore is just a really good strategy. A different tool, a similar idea. It's not anteaterification, it's just specializationization. You see this partial convergence everywhere once you start looking. Bears and raccoons are completely different animals, but both independently figured out that having flexible, dexterous paws for finding food in awkward places is worth the evolutionary investment. Owls and cats, widely different lineages, both ended up with forward-facing eyes and silent movement because hunting small prey in low light just keeps pushing evolution toward those same solutions. The environment only offers so many viable blueprints. Everything swimming fast ends up streamlined. Everything flying ends up with wings built on roughly the same aerodynamic principles. Everything eating hidden insects inside fortified nests ends up, one way or another, looking a little bit like an anteater. It's not that everything is becoming an anteater. It's that everything dropped into an insect-rich environment with the right ancestral toolkit keeps getting pushed toward this one highly effective design, and we just happen to call it an anteater. We fortunately or unfortunately won't see full anteaterification in most non-mammals because mammals already have the flexible skeletal structure and developmental plasticity to shift their snouts, reduce their teeth, and specialize their tongues without catastrophically breaking the rest of their design. A fish or a beetle doesn't have that flexibility. Their body plans funnel them toward different solutions entirely. Anteaterification isn't some universal evolutionary destiny. It's just a repeated outcome in a specific group of animals that happen to be built in a way that keeps funneling them toward the same extraordinary design. Thank you guys for watching, and whatever you do, don't develop a taste for termites.